Okay, in this video, we're going to evaluate some trigonometric ratios without using a calculator. So here's a ratio you should be able to evaluate without a calculator. Cosine of 2 pi by 3. Now 2 pi by 3 is not one of your special angles, but it's a multiple of your special angle. So that's why you can do it. So the first step when doing a question like this is you have to figure out which quadrant you're in. So sometimes it helps just to do a kind of quick sketch. If not a sketch, you can kind of visualize it. You have to decide where is 2 pi by 3. So remember that pi is half a rotation. This is 2/3 of pi. So 2/3 of pi, what I usually suggest is break pi, which is half a rotation, into thirds. Then, so you have 1, 2, 3. We've got 2/3. So we're in the second quadrant. So we know that this angle is in the second quadrant. Now by the CAST rule, C-A-S-T, we know that cosine will be negative in this quadrant because sine is positive. So we know the answer is going to be negative. When we're dealing with the trig ratio for an angle in the second quadrant, or any angle not in the first quadrant, you have to look at the related acute angle. So the related acute angle to 2 pi by 3 is going to be this angle, which is pi by 3. So this is going to be equal to negative cosine of pi by 3. Cosine of pi by 3 is one of your special angles, one of your special ratios. So you just have to know that one. You have to know cosine of pi by 3 is 1/2. So this is going to be equal to negative 1/2. Okay, so that's how you do it. Let's look at another one. Tangent of 7 pi by 4. So again, you have to decide which quadrant, so I draw it. So pi by 4, or 7 pi by 4, but you're looking at this part, the pi by 4. So what you want to do is divide pi, which is half a rotation, into fourths. But you need 7 pi, so that's going to be more. So like 1 pi, 2 pi, 3 pi, or 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4. You have to keep going. So divide this into fourths. So we have 5 pi by 4, 6 pi by 4, and 7 pi by 4. So you are in the fourth quadrant. We know that tangent is negative in the fourth quadrant. So this is going to be negative. You're going to define it in terms of its related acute angle. So it's going to be tangent of, and what angle would be the related acute angle? That's this one here, which is just pi by 4. So you have negative tan of pi by 4. Tan of pi by 4 is a special angle, so you should know that that is 1. So that's how you evaluate this. Just quickly to mention it, a lot of people when they first start dealing in radians will always convert back to degrees. I want to try to make the point here that this is far easier than degrees. You might not believe me at first, but let's say we took a similar example and did something like, in this one we're going to go in degrees. Sine of, let's go 210. So part of the reason people like degrees better is they have a better sense of where 210 is. They know it's past 180, so right here, which is true. It might be easier at first to figure out where it is, because you don't have to divide things into sections, although once you get a handle on this, this should be pretty easy dividing it into fourths or thirds. But then they have to remember, okay, the related acute angle, what's the related acute angle? You have to remember, okay, the way you get that is sine of 210 minus 180, which is not that hard, right? So that would be sine of 30. And then the sine of 30 is 1/2. But just consider the same example in radians. It would be sine of 7 pi by 6. So pi by 6, so 7 pi by 6, you're dividing into pi by 6s. So 1, 2, 3, 4. So you have 1, 2, 3, 4, 5, 6, and then one more. So 7 pi by 6, so you know you're in your third quadrant. Oh, sorry. This should be negative because of the cast rule. So you had to add that. Same thing over here. You're in your third quadrant, so you got to add the negative. Over here, you had to kind of work out what the related acute angle is. Here, the related acute angle should be very simple. If it's 7 pi by 6, the related acute angle is just pi by 6. Don't have to really do much work to get that. It's always just going to be pi by whatever the denominator is. Same for the one up here, right? 7 pi by 4, the related acute angle was pi by 4. Over here, the related acute angle, pi by 3. So in a sense, and I think in a very real sense, it should be easier to work in radians than degrees. You just have to get a feel for the fractions. One other one that is worth looking at is something like this. Let's say you have sine of, let's go 3 pi by 2. The problem with this one is that 3 pi by 2 is not a special angle. Although it is one you should still know. 3 pi by 2 is 3/4 of a rotation. And the problem with the angle at 3 pi by 2 is there's no related acute angle because you can't draw a triangle, right? And that would be the case if your angle is pi or pi by 2. Any angle that's on your axes, you can't draw a related acute angle. So what you have to do is you have to remember that that definition of sine theta being y over r, just pick a point on what would be the terminal arm. So for sine of 3 pi by 2, the terminal arm is the negative y-axis. So just pick the coordinates of any point. Usually I suggest -1 to be your y value or x value if it was on the x-axis, but use this as your point. So sine of 3 pi by 2 is going to be equal to y over r. Y is going to be equal to -1, and r, remember that x squared plus y squared equals r squared. So if x is 0 plus -1 squared equals r squared, then r is 1. So you're going to have -1 over 1, which is -1. Okay? So anytime you have an angle where it's 3 pi by 2 or pi by 2 or 0 or 2 pi, any angle that puts you on your y-axis, your x-axis, your negative y-axis, or your x-axis again, you have to kind of think of it in terms of this. You can't think of the related acute angle because there is no related acute angle.